Hello from two students. Welcome for our third lesson in chemistry. And today we are still going to continue with structure and bonding. The subtopic is the first 20 elements. The first 20 elements. So in our study, our objectives are two. That is to name the first 20 elements and also to give their symbols, and also to write the electronic configurations of the first 20 elements. Those are our two objectives. So let us look at the first 20 elements, and we are going to have a table. I hope you can see that table, but for clarity, I'm going to draw just a section of it here so that we can fill it together. So the first column is the element. The second column is the atomic number, or the symbol. The elements. The third column is the atomic number. We've talked about the atomic number. The third is the number of protons. The fourth are the number of electrons. The fifth column, the number of neutrons. The sixth column is the mass number. Yes, so we are going to look at the first 20 element, and it is advisable that you know this element in the order in which they appear. That is from atomic number 1 up to number 20. And remember, atomic number is the number of protons in the nucleus of an element. So the first element is normally hydrogen. Our first element is hydrogen with a symbol of capital H. In Form 1, you learned that when giving symbols for elements, the letter, if it is one letter, it must be capital. If they are two letters, then the first one must be capital, the second one a small letter. So hydrogen is our first element in the atomic number. Atomic number 1. Atomic number is the number of protons. So a number of protons is the same as the atomic number. So just 1 protons. In any atom, the number of protons are the same as the number of electrons. So protons and electrons are the same. And then the mass number of hydrogen is normally 1. Now we said that mass number is equal to protons plus neutrons. So if the hydrogen has a mass number of 1, then and it has 1 proton, then we can calculate the number of neutrons. So neutrons will be 1 minus 1, which is 0. So this thing has no neutrons. So hydrogen has no neutrons. Then the second example is helium. The second element is helium. Helium has a symbol of He, capital H, E. Helium is number 2, atomic number 2. Protons, atomic number is the number of protons. So 2 atomic number 2 means 2 protons. Protons are the same as electrons. So we also have 2. The mass number of helium is 4. So if mass number of helium is 4, the neutrons will be 4 mass number minus protons, which are 2. So neutrons are also 2. neutrons are 2. So mass number, atomic number, plus number of neutrons is equal to mass number. 2 plus 2 give you 4. Or you can say protons plus neutrons is equal to mass number. The third element in our table there is lithium. The symbol for lithium is Li. So lithium is number 3. Protons are also 3 because atomic number is the number of protons. If protons are also 3, electrons are also 3. But the mass number of lithium is 7. So mass number minus number of protons will give you the number of neutrons. 7 minus 3 will give you 4. Move on to the next example. The next example here is beryllium. So we have beryllium. Beryllium is B, capital B, small e. When writing symbols, don't adjoin the letters. The letters should be separate. This is number. This one is going to be our number 4. Protons is the same as the atomic number. And protons and electrons are the same. The mass number of beryllium is 9. So neutrons will be mass number minus atomic number, which is 5. Another example is boron. Boron here is atomic, has a symbol of B, capital B, boron, which is number 5. Atomic number is the same as the number of protons. Protons and electrons are the same, are equal. Then the boron is number 11. So 11 minus the atomic number, you get 6. That is the first part of our table. The second part of our table will be your assignment now. Now you can use that one to check whether you have gotten something. So you can fill in for carbon, fill in for nitrogen, fill in for oxygen, fill in for fluorine and neon. Then this page, you can fill in sodium, which is number 11, magnesium number 12, aluminium number 13, silicon number 14, phosphorus number 15. Okay, let me give you an example of phosphorus. Phosphorus. Like phosphorus is P. Phosphorus, like there we are given the protons to be 15. So protons are 15. What else are we given? We are given neutrons to be 16. Then we are told to complete the table. So in completing the table, we know that atomic number is the number of protons. So protons and atomic number equal. The number of protons and electrons are the same. So 15 protons, 15 electrons. What else? Again, mass number is equal to protons plus neutrons. Protons are how many? 15. Neutrons are 16. You get 31. So the mass number of phosphorus is 31. That is how you fill that part of the table. Then sulfur is number 16. You are given the protons and neutrons again. Fill in the atomic number and the mass number. You come to chlorine. The mass atomic number is missing. Chlorine is Cl. The protons missing, but you are given electrons, 17 electrons. Neutrons missing. You are given again the mass number, so fill in the missing parts. Come to argon. Argon is Ar. The atomic number is missing, but the protons are given as 18. So use the protons to get the atomic number. Use the protons to get the number of electrons. Then use the atomic number and the mass number to get the number of neutrons. You come to potassium. Potassium is K, and your given atomic number is 19. So use the atomic number to get the number of protons, to get the number of electrons. Then mass number, add neutrons plus atomic number. And the last in this list is calcium, which is number, we are given Ca as the symbol. In between, atomic number is missing, but you have the protons. So use the protons to get atomic number, and then fill in the remaining parts. So those are the first 20 elements. Given the atomic number, the protons, the mass number. So in case you find a question that requires you to actually find out any of those properties of an atom, then that's how you're supposed to do it. Now our next part is going to deal with what we call the electron arrangements. Our next part is going to deal with the electron arrangements. So, electron arrangement is also called electronic configuration or electron configuration, which is actually the distribution of electrons within the energy levels. We said that at the center we have the nucleus, where we have protons and neutrons. And then surrounding the nucleus are the energy levels. On these energy levels, we have electrons revolving around the nucleus. So we are going to see the electron arrangement of the first 20 elements. Now, our learning is going to be based on this table again, and I'm going to have just a section of it where we will have the elements, and I will be using symbols. Then again, we'll have the atomic number, then the number of electrons now, because we are dealing with the electron arrangements. I'm going to ignore protons and neutrons. And then we are going to come up with the number of electrons. Number of electrons in the various shells or energy levels. Various shells or energy levels. Then I will have electron electron arrangements. Electron arrangements. So I will have K, you know what they mean, those are energy levels, L, M, N. I will have them like this. Then I will draw a line like that. So what do I have here? I have the element, then the atomic number of that element, number of electrons, then the number of electrons in the various shells. Remember, we have the nucleus, then the first energy level, the second energy level, the third energy level, the fourth energy level. So K is the first one. L is the second one. M is the third one. N is the fourth one. So we are going to distribute the electrons in these energy levels. Now the first element is hydrogen. That's where we start. And we say the hydrogen is atomic number 1. How many electrons? 1 electron. And remember that in our last lesson we talked about the distribution of electrons, where we say the first energy level can accommodate 2 electrons, the second energy level 8 electrons, the third energy level also 8 electrons. Then the remaining electron will move to the fourth energy level. So this energy level can carry a maximum of 2 electrons. How many electrons do we have? 1. So this 1 electron will move to the first energy level. Second will be empty, third will be empty, the fourth will be empty. So the electron arrangement is 1. We move again. The second element is helium. Helium is atomic number 2. 2 electrons. The first energy level can take 2 electrons. So these 2 electrons will go to the first energy level. There is nothing for the second, third, fourth. So the electron arrangement is 2. We come to lithium. Lithium is number 3. Atomic number 3. How many electrons? 3 electrons. The first energy level can take 2. So we will assign 2. How many are left? From these 3 electrons, 1 electron is remaining. That 1 electron will move to the second. So the 1 electron will move to the second. So let me put a boundary there. So the electron arrangement will be 2, 1. We read it as 2, 1. 2 electrons in the first energy level, 1 electron in the second energy level. The fourth element is beryllium, which is number 4. How many electrons? 4 electrons. The first electron will move, the first 2 will move to the first energy level K. So this one will only take 2 electrons. It is now filled. The remaining 2 will move to the K. So it will be 2, 2. We close that chapter. Then the fourth is boron. The fourth here is boron, number 5. How many electrons? It has 5 electrons. Now, the first energy level will take how many? The first energy level will take 2. Then it is satisfied. How many are left out of 5? 3. The 3 will move to the second energy level. So we have 2, 3. Move on. So then we have carbon. But now I will skip carbon. But before that, now that it is part of my example on my table, carbon is number 6. 6 electrons. 2 will move to the first energy level. 4 in the second energy level, because there are 6. 2 plus 4 is 6. The third one is empty. Fourth one is empty. We have 2, 4. So make sure you do for nitrogen, the same thing. Oxygen, same thing. Fluorine, you fill in. Neon, you fill in up to where you have there. The second part of the table, sodium. I will do the one for sodium. Sodium is number 11. How many electrons? 11 electrons. The first 2 electrons will move to the first energy level. Out of 11, but remember 9. And 9, 8 will move to the second. The second energy level can take 8 electrons. Remember 1, because 2 plus 8 is 10. Remember 1. 1 will move to the third energy level. So you have 2, 8, 1. 2, 8, 1. Can also do for you there for magnesium. Now, magnesium is number 12. How many electrons? 12. The first 2 electrons will move to the first energy level. Then, second energy level will take 8. Remember, 2. 2 will move to the third. Now you have 2, 8, 2. That is for magnesium. So again, for your practice, complete for aluminium, silicon, phosphorus, then sulfur, chlorine, argon. Now, when we come to potassium, I'm going to work out the one for potassium because potassium is number 19. How many electrons? 19 electrons. So the first 2 electrons will move to the first energy level, meaning we have 19 electrons. We have subtracted 2. But we still have how many? 17. The second energy level will take 8. So from 17, we subtract 8, we remain with 11. The third energy level will take 8. So from, again, 11 will move 8, remember? 1. That one will move there. So for potassium, it is 2, 8, 8, 1. 2, 8, 8, 1. So that is the electron arrangement for potassium. So you can also complete for calcium so that you have the electron arrangement for calcium. That one brings us to the end of our class today. I hope you have understood how you can write the electron arrangement for the various elements, the first 20 elements. Thank you for watching and continue wait for the next video where we meet and learn something new on the first 20 elements.